Okay, so just to be clear, let's make sure we're good so far. If there are 4 terms, what's the only factoring method you've learned for 4 terms?
Grouping.
Grouping, good. If there are 3 terms, what are some of the different methods we've learned?
The guess and check.
Guess and check, or the
AC method.
AC method, those can work. Also, there's perfect square trinomials like we were talking about earlier. And then some of them are those really basic ones, which is kind of like the guess and check where you just have the x squared in front. So you don't have to do any longer methods. Good. Now, for the last few problems today, we're going to look at binomials. And there's several rules you guys have learned for binomials. So let me go over the rules before we approach the problems, right? So for binomials, there's 3 methods that you guys have learned. One is called the difference of squares, right? What does the word difference mean in general?
Subtract.
Subtraction. So this means you're subtracting 2 terms that are perfect squares. Okay, so the name kind of tells you what's going on. A squared minus b squared. How does that factor?
A plus and A minus B.
A minus B. And the order doesn't matter. So if you had A minus B and then A plus B, that would be fine. Okay. Is there a formula for the sum of squares?
No.
No, the sum of squares is actually prime. So if you have A squared plus B squared, that is going to be prime, because if you tried to write it as like A plus B times A plus B, there would end up being a middle term, right? So we're kind of missing the middle term. And if there was a middle term, then it would be a perfect square trinomial. But it's kind of like we've taken a perfect square trinomial and removed the middle term. That doesn't work. It no longer factors. Okay. But then we also learned a difference of cubes and a sum of cubes.
Yeah.
So these are all the ways you've learned to factor binomials. Now, these formulas are very similar because they both have an A, a B, and then an A squared, AB, B squared. The only difference is the signs. And I'm not sure if the videos teach you, do the videos teach you a shortcut to learning the signs?
I think so.
What do they call it?
Well, we learned in the lecture too, so.
Okay. Oh, that's right. She makes
what. Yeah. Yeah, so she called it SOAP.
Perfect. Which stands for what? Do you remember?
I don't remember exactly what it stood for, but I know it's like, I know how to do it.
Okay. So the S stands for same. The O stands for opposite. And then the AP stands for always positive. And that's referring to the sign. So what happens is the first sign is the same as the problem. So if it was minus, it stays minus. If it was plus, it stays plus. The second sign is the opposite. And the last sign, no matter which problem, is always positive. I was so excited when I learned that. I had already been teaching this for several years. And even as an instructor, I sometimes found it hard to remember where the signs went. So I'd have to almost like multiply it out in my head to try to make sure I had done it right. So I was so excited when I finally learned this trick, several years ago now. I was like, oh, that's so much easier. Like, finally, I can remember it. Okay. So what you need to be able to do for these problems now is, first of all, you recognize that there's only 2 terms, right? So in all of the remaining problems, there's only 2 terms. So it's going to be one of these methods that I just went over. But you have to be able to look at the problem and figure out what it is. So is it a difference of squares, a difference of cubes, or a sum of cubes? So the difference is pretty easy to figure out, right? Because if you see a minus sign, you know it's going to be a difference. So then you have to look at the numbers and say, are these numbers perfect squares or are they perfect cubes, so that you know whether or not you have a difference of squares or a difference of cubes. So which one is number 44?
Squares.
Squares, okay. Square formula is a lot easier than the cube formula, right? But you have to figure out what is being squared. So this is why you can even say, like, just take the square root of each number, right? Or you can write it with the parentheses like we were talking about earlier. So what is being squared in number 6 for 16x squared? Or what is the square root of 16x squared?
4x.
And then for 81?
9.
9. Good. So then what would be the answer? If 4x is like your A and 9 is like your B, what would be the answer?
4. Oh, go ahead. 4x minus 9. And then 4x plus 9.
Good. In this formula. Good. Okay, what about number 45? Is that a sum or a difference?
Difference.
Difference. And then are those perfect squares or perfect cubes?
Squares.
Squares again. Okay, so what is the square root or what is being squared for the first term?
The xy.
Xy, good. And then for the second term?
It'd be 7.
So then how would this factor?
So it would be xy minus 7 and xy plus 7.
Very good. How can you check these problems, by the way?
FOIL.
FOIL, exactly. Still works every time. Good. What about number 46? Is that a sum or a difference?
Difference.
Difference. And then are those perfect squares or perfect cubes?
Squares.
So how could you rewrite it? What is being squared to get x squared?
X.
X. And then what about the fraction?
1 over 9.
1 over 9. You can think of it when you take a square root of a fraction, like you're taking the square root of the numerator. So the square root of 1 is 1. And then the square root of the denominator, the square root of 81 is 9. So that's how you come up with 1 over 9. Good. So then how would you write this answer?
X minus 1/9 times x plus 1/9.
Awesome. Very good. So any questions on the difference of squares?
No.
No? Okay, we only have a couple more problems to go. And let's pretend, because you know I'm like this, you can't read. Because sometimes it just says factor, right? So you need to know what to do. So you have two terms. So once again, you know it's either going to be the difference of squares, the difference of cubes, or the sum of cubes. So here, right away, you can figure out that it's going to be what?
Addition. So
it's addition, so it's going to be a sum. You do need to make sure it's a perfect cube and not a perfect square, right? Because if it's the sum of squares, you actually know it's prime and you're done. Yeah. But this is obviously the sum of cubes because 8 is not a perfect square, but it is a perfect cube. Okay, so what was being cubed to get y cubed?
Y.
Y. And what is being cubed to get 8? Or think about it, what is the cube root of 8?
2.
2. Good. So this could be y cubed. This could be 2 cubed. So those are going to be like your A and your B in the formula that I did above, which I'll rewrite because it's now off the screen. Okay, so then what would be the answer here?
It'd be y plus 2 times y squared minus 2y plus 4.
Perfect. So you could plug it in y squared minus y times 2, which I agree is 2y, plus 2 squared, which I agree is 4. Very good. So you gave me the final answer. How could you confirm that that answer was correct?
Multiply.
Technically, FOIL doesn't work here, but the idea, I know what you mean, is that you're multiplying or distributing it all out like we did in a problem way at the beginning of this review. Good. Okay, so last but not least, number 48. What is that?
Difference of cubes.
Difference of cubes. Difference because of the subtraction sign. Cubes because those are perfect cubes, not perfect squares. So what is the cube root of 27x cubed? Or what did you cube to get 27x cubed?
3x.
3x. And then what about the other term?
5.
5. Good. So 3x cubed and 5 cubed. See if you can figure out the final answer there. So what do we get?
3x minus 5.
Mm-hmm.
And then times 9x squared.
Good, because you had to square the term 3x, so it becomes 9x squared. Good, the 3 and the x get squared. Awesome.
And then plus 15x.
Good, you had to multiply 3x times 5. Mm-hmm.
And you do 5 times 5, which is 25.
Very good. And then that would be your answer. Fantastic job.